Welcome to the last video of this video tutorial series, where you learn how to run federated AI simulations using the Flower framework. Everything we have seen so far, everything in this series, is equally applicable to simulations and non-simulations. What does this mean? It means that all the changes you have learned to do to your client app and your server app can be used when you take those applications out there in the real world, whether you want to run them in real, different distributed servers, or even on embedded devices like Raspberry Pis. The only concept that is not applicable to non-simulations is what we were covering in the previous video, where we control the degree of parallelism of the simulations by assigning different level of resources to your client app. In this video, I'm going to do a quick recap on everything we have seen so far. I will point you to different resources in the Flower documentation and other examples you can take a look in order to take your Flower simulations to the next level, doing more complex tasks and things different to image classification with a tiny model. So let's see. We started our journey with a simple command, Flower new, which it guided us through the process of creating an app. We typed Flower new, it was asking us for an app, my recap app, for example. It asked us for a name, and then the final question, it asked us for a template to use. We chose the PyTorch template, but all the concepts you have seen here are equally applicable to all these other frameworks. The great thing of starting with one of these templates is that you get a client app and a server app and everything else needed, so you can run it right away with a command that we saw called Flower run. In the different videos, we saw how we can easily customize the dataset we got by default with our Flower new command. We remove the Cypher10 dataset and we use the fashion MNIST. We also make use of a more sophisticated partitioner that is available in Flower datasets. You can find that and much more information about how Flower datasets work, including the visualization tools we went through in the second video, in the Flower datasets documentation, flower.ai docs datasets. We also spend some time customizing the behavior of our server app. In particular, at the beginning, we saw how we can make use of the different callbacks that are available to our strategy. We saw how we can configure at runtime hyperparameters that get to be used by the client apps, like, for example, the learning rate. We define different ways of aggregating metrics sent by the evaluate and the fit methods, even custom metrics that need some form of serialization. And we also saw how you can do centralized evaluation of your global model if you have access to a centralized test set or evaluation set. We then took it a step further and saw how to create a fully custom strategy. In this case, this custom Fed average, what we did was to inherit from Fed average and add a little bit of code, just a few lines to customize the way our global model checkpoints are being saved. Because here we are using PyTorch, we did this in the PyTorch way. All these steps are equally applicable to other machine learning frameworks. For example, if you are using a TensorFlow model, you will just replace these 3 lines of code with the preferred way of saving a model in TensorFlow or with Keras. We also saw how we can override some of the existing methods, and all those metrics that get computed behind the scenes, like what was the global accuracy or the distributed accuracy, we saw how we can customize how they get saved to our local directory. For example, we decided to save them as a JSON that we can very easily inspect and reuse later on for making, for example, plots. If what we wanted is to automate the generation of those plots and have a nice dashboard, we were able to quite seamlessly integrate tools like weight and biases and others in order to push all those metrics to our dashboard in weight and biases. that can be shared easily with other researchers or colleagues. Then we looked into how we can make our client apps stateful, because client apps by default are ephemeral, which is great for simulations. If there are occasions where we want to save some intermediate results or some metrics that are relevant for the client app to be aware of in subsequent participation rounds. In this case, what we did was to save the previous training loss from the previous rounds into a local memory that is available to each individual client app. And how is this local memory or state implemented? We saw that this can be done by means of using the context. Remember, the context is the only input argument that is passed to this client function that generates, in the end, everything we need to create a client app. So this is the preferred way of achieving stateful clients. And then in the next videos, we saw how the simulation engine works behind the scenes. And in particular, we pay close attention to how to define client app resources. This is important because it allows us to take the most out of our system resources and run simulations as fast as possible. This is also quite critical if you, for example, you have a tiny model that you want to federate. Well, you probably can pack the execution of that of many client apps in parallel in your system. We saw how to do that thanks to, in part, to the simulation, how to run simulations documentation, which is quite lengthy, but I recommend you taking a look to get a full grasp on how it works. And of course, everything taught here is orthogonal to what is the workload you do and the machine learning framework you use alongside Flower. I recommend you taking a look at the how to run simulations documentation. When it comes to stateful clients, there is also a page in the documentation that shows you how to do that, how to save metrics, like for example the training loss we saw, but also how to save arbitrary data structures that need to be serialized, or even model parameters if you want to persist some of the locally trained models in the client app. So this is everything we have been covering so far. It was quite straightforward to run all these applications. If you want to see other examples of tasks that you can federate very easily, I recommend you go into the Flower repository, go to the examples, and here you have a very long list of different types of examples. There are the quick start examples that show a simplified workload that can be run in simulation. For example, quick start PyTorch is roughly what we had after the second video in our tutorial series. You can achieve the same thing with other frameworks like TensorFlow, Pandas, MonAI, MLX if you are on Mac, with JAX as well, Hugging Face, and so on. The content we have seen in this tutorial series roughly matches the content of the advanced PyTorch example. So please go take a look if you want to see the same content but presented in a slightly different way. An equivalent example is there also doing the same things but using TensorFlow, and you will see that the only bits of code that differ are those where the machine learning specific APIs are used. So this means how the client does the local training, how the client does the local evaluation, and how we save the checkpoints. The rest is really framework agnostic, which makes Flower ideal to a great variety of projects. As I mentioned, this client app and server app, you can run them in the real world without doing simulations. And for that, I would like you to take a look, for example, to this embedded devices example, which walks you through the whole process of setting up a small device like a Raspberry Pi that you can later on use to run your client app and server app. For example, you can run your server app in a big Raspberry Pi and your client apps in different Raspberry Pis. And you can do that through the Flower deployment engine. But stay tuned because there will be a tutorial series for that. So this is everything I wanted to show you in this tutorial series. I hope you enjoy. You will find the code for this video link in the video description below. Remember, if you want to reach out to us or you want to propose new learning materials, you can do so via our Slack channel, link at the top. Just scan the QR code. You can, of course, post your more elaborated questions or discussions in the Flower Discuss. We are all in all platforms in social media, not only YouTube, also LinkedIn and X or Twitter. So feel free to reach out to us in that way as well. So hope you enjoy. Give us a star on GitHub if you enjoy Flower. See you. Bye.